The rule in getting the derivative of a rational function in this form, 1 over x raised to n, is actually equal to negative n over x raised to n plus 1. This n exponent here is a positive integer, so you are just going to get this n and locate it. So nakikita natin it's negative n on the numerator, and we need to add 1 on the denominator. But how did we get this one? Remember that when we talk about rational function, we are utilizing the rule of quotient, and that is the derivative of 1 over x raised to n as part of our proof will give us, okay, we need to square the denominator as suggested or as part of the rule of quotient. Get the derivative of the numerator, which is 1, and the derivative of the numerator is 0. So numerator derivative times the denominator x raised to n, then subtract the derivative of the denominator x raised to n follows the rule of power, and that is n x raised to n minus 1. So we have n times x raised to n minus 1. Multiply that to the numerator, which is 1. So this is already 0. So we copy. So we now have negative n times x raised to n minus 1 over x raised to n, or this will now be 2n. So 2 times n is 2n. We can expand this x raised to n minus 1, and it will now be written into negative n times x raised to n times x raised to negative 1, okay, over x raised to 2n. Now, recall or remember that x raised to 2n is actually x raised to n times x raised to n. Therefore, bring out x raised to n times x raised to n here. We will now cancel x raised to n on the numerator. So ano ang natira? We now have negative n times x raised to negative 1 over x raised to n. And this negative integral or negative 1 on the numerator, pwede nating ibaba. Okay? So it will now become negative n over x raised to 1 times x raised to n. Now combine, since they have the same base x, so we have negative n over x raised to n plus 1. So dyan galing yun. Also, we can rewrite this one into negative of n over x raised to n plus 1. So in the understanding, we will just need to observe the exponent of the denominator and locate it on its position. So just like on the first example, g of x is equal to 1 over x raised to 3. So this is the exponent, n is equal to 3. So ilocate lang natin siya. So we have g prime of x is equal to negative 3 over x raised to 3 plus 1 as seen in the rule. So we now have negative of 3 over x cubed plus 1. Next, we have f of x is equal to 1 over x. The exponent is 1 here. Okay, so we have f prime of x is equal to negative 1, where n is equal to 1 because the exponent is 1, over x raised to 1 plus 1. So we have negative 1 over x squared. On the third example, h of x is equal to negative 4 over x raised to 5. But in here we have a constant 4. So we can actually factor it out. So bring out negative 4, and we have another factor 1 over x raised to 5. So we're going to use the rule of constant here. We're going to separate negative 4. So h prime of x will now be negative 4 Now get the derivative of 1 over x raised to 5, where n is equal to 5, so we have x raised to 5 plus 1 and negative 5 on the numerator, as we follow negative n here. So h prime of x combined negative 4 times negative 5 is positive 20. So we have 20 over x raised to 6. So that is how we get the derivative of these rational functions using the rule. Now, if you're asked to find or evaluate at a given x, then you just need to get, or you're going to evaluate using the derivative, that you need to get the derivative first of the function before going to evaluate. So let's say, for example, in number 1, let's say you're asked to get g prime of 1. So g prime of 1 will now be equal to negative 3 over 1 raised to 3 plus 1. That will be equal to 4. So this is negative 3 over x raised to 4. Okay, so we now have the answer is negative 3. So g prime of 1 is negative 3. So when you say g prime of 1, you need to get first g prime of x and let x be equal to 1. On the second function, let's say for example you're going to find f prime of 2. So when you find f prime of 2, then substitute 2 to the derivative, so we have 1 over 2 raised to 2. The answer is negative 1/4. On the third example, let's say for example you're going to get h prime of, let's say, negative 1. So substitute, so we have 20 over negative 1 raised to 6 is positive 1. So the answer is 20. So whenever you differentiate, the first thing you need to do is observe the constant. So just like this, pi over 3 is actually constant because this can be expanded and it will be pi over 3 times 1 over x raised to 2. So if you're going to get p prime of x, then you just use a constant rule. So separate pi over 3 and now get the derivative of 1 over x raised to 2. So following the rule, we have x raised to 2 plus 1 and copy 2, negate it. Okay, so negative 2. So this will now be negative 2 pi. So negative 2 times pi here is negative 2 pi. So over 3 times x raised to 2 plus 1 is 3. So let's say for example you are asked to get p prime of 2. Then your answer will be 2 pi over 3 times 2 raised to 3. So 2 raised to 3 is equal to 8 times 3, that is 24. So 2 over negative 2 pi over 24, and that will be 1 and 24. 2 and 24 are divisible by 2. So we have negative 1 over 12. So the answer is pi over 12, negative pi over 12. On the second example, mx is equal to 1 over 9x raised to 8 plus 2 over x raised to 4. So get the derivative, so we have m prime of x is equal to, separate the constant 1 over 9, separate 2 constant. Now get the derivative of 1 over x raised to 8. So that will be x raised to 8 plus 1, and this is negative 8. Get the derivative of 1 over x raised to 4. So this will be x raised to 4 plus 1, and this will be negative 4 on the numerator, as to follow the rule. We just need to follow the rule. Locate lang ninyo ang exponent. Okay, so we have negative 8. So negative 8 times 1 here is negative 8, and 9 times x raised to 9. So we have now 9x raised to 9. Okay, so 2 times negative 4 here is negative 8 over x raised to 5. So what if you're asked to get m prime of 0? So m prime of 0 is not possible already, okay, because the denominator should not be 0 here. So it means to say m of x is not differentiable at x that is equal to 0. So bawal ang x that is equal to 0 when you get the value after differentiating m of x. So we can solve this problem using the quotient rule or even the product rule. We start from using the product rule. So we have a time method A, product rule. The derivative of x plus 1 is 1, and the derivative of 1 over x cubed is negative 3 over x raised to 4, following the rational function. So the derivative of the first factor is 1 times the second factor plus, so don't forget addition for product rule. The derivative of 1 over x cubed is negative 3 over x raised to 4 times the first term x plus 1. So we have 1 over x raised to 3. Now distribute negative 3 times x plus 1, so we have negative 3x minus 3 over x raised to 4. The least common denominator of this is x raised to 4. We're going to multiply this 2 to x raised to 4. Okay, so it will give us x raised to 4 in denominator. So x raised to 4 divided by x raised to 3 will give us x. So minus 3x minus 3. Combine like terms, so we have negative 2x minus 3 over x raised to 4. So this will now be the derivative of the given function n using the product rule. Now using the quotient rule, we have this answer. Remember that x plus 1 times 1 over x cubed is actually equal to x plus 1 over x raised to 3 after multiplying, and that will be the quotient. Okay, so this will now be square the denominator x cubed we start from the derivative of x plus 1, which is 1, multiply that to the denominator x cubed. The derivative of the denominator x cubed is 3x squared using the power rule. Now multiply that to the numerator x plus 1. That will become x cubed minus 3x cubed minus 3x squared. After distributing, this will now be x raised to 6. Combine like terms, x cubed and negative 3x cubed will become negative 2x cubed minus 3x squared over x raised to 6. Factor it out, we can bring out x squared. Okay? Masusunod yung lower exponent. So this will now be negative 2x minus 3. So if factor din natin ang denominator x raised to 6, it will become x raised to 2 times x raised to 4 using the rule of power. Power for exponent 2 plus 4 is 6. Now cancel out x squared here. So we now have negative 2x minus 3 over x raised to 4. They have the same value. So it doesn't matter if you want to use product or the other. If you use the product rule, make sure that you're confident on it. And if you try to use the quotient rule, also beware of its rules. They may have the same, and they may have different ways, but you will end up with the same answer. In differentiating radical functions, we're going to observe here the index. Okay, observe the index. So nth root of x. Ang gagawin mo lang dito, bring down, copy the index, that is n. The index n does not change, siya pa rin yun. And then index n minus 1 at yun magiging exponent of x in the radicand. So paano tayo nagkaroon ng ganitong rule? Remember that nth root of x can actually be written into x raised to 1 over n. In the rule of power, it doesn't necessarily mean that the exponent must be an integer. Pwede din magkaroon ng exponent that is fraction. So kapag fraction ng exponent, ina-expect natin na magiging radical number ang given. So what if we make use of the fractional exponent and then apply the rule of product or the rule of power for derivative? So it will become the derivative of x raised to 1 over n is equal to, bring down the exponent, 1 over x raised to n times x raised to 1 over n minus 1. So that will become 1 over n times x. So this one can be written into n over n, right? So we have 1 over n here. So kapag ibaba natin ito, magkakaroon tayo ng 1 over n, or i-rewrite natin yan magiging x raised to n minus 1 over n, and then this is negated. Okay? Kasi kapag erase natin ito sa negative 1 times negative 1, then pwede magbaliktad ng pwesto ang n sa numerator, from negative n magiging positive n minus 1. Okay? That is also true kapag you have x raised to a. Pwede itong magkaroon ng x raised to a raised to negative 1 times negative 1. Anyway, negative 1 times negative 1 is simply 1, and that will become x raised to negative a over negative 1, which can also be x raised to, or 1 over x raised to a raised to negative 1. Anyway, that's just the power of exponent. Okay, so that will now be 1 over n. So pag ibaba natin yan, itong negative sign na to magiging positive na. So we have x raised to n minus 1 over n. And after that, we can, kapag fractional yung exponent, pwede siyang maging radical number. So we have 1 over n times nth root of x raised to n minus 1. So itong nasa numerator, magiging exponent ng x, at itong denominator n ay magiging index. So in the first example, h of x is equal to 4th root of x. The index is 4, so gagawin mo lang dito, h prime of x will now be copy the index, which is 4. This is automatically 1. So 1 over 4 times 4th root of x raised to 4 minus 1. And that will become 1 over 4 4th root of x raised to 3. On the second example, the exponent here is understood to be 1, and the index is 2. So we have f prime of x will now be 1/2 square root of x plus 1, because 2 minus 1 is simply 1. On the third example, the index is 3. So we have g prime of x is equal to 1/3 cube root of x raised to 2. Okay, because 3 minus 1 here is 2. So the same will happen if you're going to determine or evaluate the function. Let's say you're looking for h prime of 1. So the answer is simply 1/4. So here, let's say f prime of 0. So the answer is 1/2 g prime of negative 1. The answer is 1/3. For as long as x here should not be 0, or here should not be 0, and the other should not be negative 1, and this should not be 0, then all are differentiable. So dito naman sa next example, the exponent here is 1. So we have p prime of x is equal to 1/5 fifth root of x raised to 4. Because 5 minus 1 is 4. So kunwari pinasolve sa'yo, what is p prime of, let's say, 2. So you have 1/5 root of 2 raised to 4. So your answer is 1/5 fifth root of 16. So the next is b of x is equal to 7th root of x. So b prime of x is simply 1/7 7th root of x raised to 6.